refer the last lectures. So in this lecture, in the last lectures, we have see the KCL, KVL. So as you know, what is a KCL? So KCL stands for that it's electrical circuit at any point of time. The algebraic sum of the current at all the conductors meeting at any point is 0. So you can see graphically the Kirchhoff's current law, KCL. Incoming current is equal to outgoing currents. Then we see the KVL, Kirchhoff's voltage law. So KVL states that algebraic sum of the potential differences in any loop that must be is equal to 0. So you can see here in this figure, we have one voltage source, two resistance R1, R2. Current is flowing from the voltage source is I. So here one of the students asked that how to provide the polarity to the voltage, resistance and voltage source and resistance. So as we know that you can see here the voltage source. So this voltage source upper terminal, that always a positive. The line which is bigger than second line, that is always positive as compared to the another line. Okay, so we always know that how to provide the polarity to the voltage source or EMF. So always upper line is positive and this lower short line is negative. Okay? Then second is how to provide the polarity to this resistance. So here this plus and minus is given. Yeah. So generally current is flowing from positive to negative. So always when the current is entering in any resistance, that terminal we consider as a positive. Yeah. And leaving. Yeah. So that is a sign convention for how to provide the polarity. But sometime in the example, this polarity is not given. Okay. But we assume that the direction of current is, suppose it is clockwise, and if current is entering to the resistance, so the entering point that is considered as a positive and leaving point that is considered as a negative. Yeah. So that is given here. You can see that in the sign convention, positive voltage we consider when the travel direction of the current is from positive to negative. So you can see that here in this case, our current is clockwise direction. It means we move from positive terminal to the negative terminal of this voltage source. So that's why we consider as a positive Vs. So you can see that here we write Vs, which is positive. Then here, for this voltage drop across this resistance, I into R1. So that we consider as a negative, because for sign convention for the resistor is, if we move in the same direction of the current, then we consider as a negative voltage drop, this one. And if we move in opposite direction of the current, then we consider as a positive sign. So you can see here our direction is clockwise direction and polarity is plus minus. So we move in the same direction. So that's why we consider as a negative polarity of this resistance voltage drop. So we consider as a minus I into R1. Same way for the resistance R2, positive here, negative here. So here we move in the same direction. Our travel direction is same as a resistance polarity. So that's why we consider as a negative voltage drop across the R2 resistance. So that's why here we consider minus I into R2. So as per the Kirchhoff's law, the algebraic sum of the potential difference must be is equal to 0. So that is proof here. You can see that supply voltage plus Vs minus voltage drop across R1 minus voltage drop across R2, that becomes equal to 0. So I hope it is clear to all how to give the sign convention to in the Kirchhoff's law. Clear all of you? Okay, कौन doubt पूछो तो? Hello.
Sir, I had asked the doubt.
Yes. Clear doubt? Your doubt is clear?
Yes, sir. Thank you.
Okay. So last lecture we see the different terms related to the electrical circuits. Yes.
So could you go back to the last slide?
Okay. Yes.
So my method is slightly different.
Okay.
When you going from the negative terminal, you take the voltage as minus, but then you take everything else. So like
yes, there are different
minus
methods.
Vs.
You can also choose exactly inverse also. Okay, but you choose exactly inverse for all this
yes
EMF as well as resistance. Here, suppose you choose that the travel direction is from negative to positive, you consider negative. The
Yes.
same way you consider for the resistance also. For the opposite travel direction, you consider this one as a negative voltage drop. Okay. So consider opposite for both the resistance as well as EMF.
No, sir. If we consider the voltage as negative, but still the resistance will be positive.
How?
So I don't know. I was watching a video. Some teacher was saying that if we just need to change the signs of the voltage, but not of the resistance.
Simple thing is what?
And the current.
Supply voltage is Vs. Okay, supply voltage is Vs. Here in this circuit, you can see that supply voltage is Vs. So amount of the voltage drop across the resistance, that is same as your supply voltage. So supply voltage must be is equal to voltage drop in your circuit.
Yes.
Here. So you can write this Vs is equal to voltage drop across R1 and R2. So you can also write this equation Vs is equal to I1 into R1 positive plus
Yes.
I1 into R2
Yes.
positive. Clear? So that's way you also can write. So both the way equation becomes same. Okay, Vs is equal to I to R2, or you can write Vs minus IR1 minus IR2 equal to 0. So both equation is same. Okay, there is no difference in the two equations.
Yes, sir.
Clear? So both way you can write the KVL. You can choose any method, whatever you like. Okay.
Yes.
But we take this method as a reference, so you all can understand this. Okay.
Okay.
So in exam, when you write any equation as per the KVL, you make the sign convention common for EMF as well as resistor. Clear? As per this or exactly opposite to this. Then your KVL becomes right. Clear? All of you?
Yes, sir.
In the next topic, we will calculate the example related to the KVL, so you can get the idea about this. Okay. So last lecture we see some definition related to the electrical circuits. So first definition we see, so that elements. So I think all of you clear that what is the elements, what are the active element, what are the passive elements. Then we see the definition of network. Then any interconnection of the two or more elements, that is called as the electrical network. Then we see the definition of circuit. If any network contains at least one closed path, that is called as the electrical circuit. Then definition of active element. So definition is that any element which is capable to delivering the average power greater than 0 to the external device over the infinite time interval, that is called as an active element. So as we see in this circuit, voltage source will provide the energy, average energy greater than 0 for infinite time period, R1 and R2. So we call this voltage source as an active element. Same way, this current source is also active element. Dependent voltage source and current source is also active element. Clear? Then definition of passive element. So passive element is the element which is capable to only receiving the power. So if in your circuit resistance, inductance and capacitor are present, they are receiving the energy from the source, so they are called as a passive element. Then definition of node, point at which two or more elements are connected together, that is called as a node. Then definition of junction, point where three or more elements are connected together. Then branch, section or portion of the network or circuit which lies between the two junction point, that is called as a branch. Then definition of loop, any closed path in a network, that is called as a loop. Okay. Then definition of mesh, it is the most elementary form of loop and cannot be further divided into other loop. Or we can say that a mesh is a loop that has no any other circuit path within inside it. So that is called as a mesh. So this is all about the different terms related to the electrical circuit. You must know about each and every terms. Then after we see the mesh analysis. So what is the purpose of using the mesh analysis in the electrical circuit? Can anyone give the answer? Why we use the mesh analysis? Yes, anyone?
To find unknown current.
Value of unknown current.
Yes, very good. So find out the unknown current in your closed path, closed circuit. Clear? So mesh analysis, we apply the KVL to find out the unknown current. And it is only applicable to the planar circuit. Circuit means that branch which crossing each other. So that is called as a planar circuit. And as we know that mesh is a loop that does not contain any other loop. So during the mesh analysis, you first identify the number of meshes, and then after apply the KVL for that mesh, make the equation, and then solve this equation. So the current flowing into this mesh, that is called as a mesh current. Okay. So here for the simplicity, we assume that when only one voltage source in this example. So last time we see the example that suppose this is a circuit diagram. We have 4 mesh. So we identify the 4 mesh and assume that the current flowing into each mesh is clockwise direction. Then apply the KVL to each mesh. So we have 4 mesh. So we apply the mesh analysis. So we get the 4 equation using the KVL. And then after solve these all 4 equations simultaneously, so that we can get the I1, I2, I3, and I4. So this is the first step to identify the number of mesh. Identify the number of nodes and number of branches identified. So we have 10 branches. So as per this equation, L is nothing but number of mesh is equal to number of branch minus number of node plus 1. So you get the answer, it is 4. So by this way also you can find out mathematically. Otherwise you can identify by showing this figure also. So in this circuit diagram, we first apply the KVL to first mesh. This is our first mesh. So we get this equation, then mesh 2, this one. So we get this equation, mesh 2, mesh 3, and mesh 4. So we have 4 equations. So we use this 4 equation, and using this 4 equation we make the matrix of resistance. So you can see that first term which is related to the current I1, that is R1 plus R5 plus R7. So that is R11 in your matrix. Second term related to the I2, that is minus R7. Third term that is related to I3 is minus R5, and I4 term that is not present in the mesh 1, so it is 0. So same way you can write down the resistance matrix for mesh for all the remaining equations. So you get this resistance matrix, or you can say that mesh resistance matrix. And here the second is the 4x1 current matrix, I1, I2, I3, I4. Then it is equal to your voltage source. 4 equations at the right hand side, Vs2, 0, Vs1, and Vs1. So that you write down as a 4x1 matrix. So this is called as a matrix, resistance matrix. This is your current matrix, and this is your voltage matrix. So when you find out the current I1, at that time you replace the first column of this resistance matrix by the voltage source. Okay? And then find out the determinant. So that determinant, that is called as D1. And this resistance matrix determinant, that is called as a D. So to find out the I1, you can see here, to find out the R1, you apply this equation D1 by D. Here we take the example common for this Cramer's rules using this 3 equations. So first we understand this. So this is a matrix of resistance, current matrix, and voltage matrix. You can also write like this way also. So first identify what are the common points when you apply the mesh analysis to any circuits. So in your resistance matrix, which must be a symmetric matrix. Which symmetric matrix means here it is your matrix is 4 cross 4. Yeah. So you can write this matrix symmetrically also. So that matrix remains same. It means RKJ is equal to RJK. So all the off diagonal terms in your matrix may be negative or maybe a 0. That never be a positive. Okay. And diagonal terms, that is nothing but a sum of the resistance of that mesh. So suppose here you apply this KVL for the mesh 1. So in mesh 1, how many resistance? R1, R7, and R5. So for the first mesh, the diagonal element is what? It is the sum of R1 plus R7 plus R5. Same way for mesh 2, the diagonal element is nothing but sum of resistance of this mesh. It means R2 plus R7 plus R6. It means that the diagonal element is nothing but the sum of resistance of that particular mesh. Okay? And that always, then RKJ terms are negative, and that term is nothing but a resistance which is common between two mesh. So you can see here between mesh 1 and 2, the common resistance is R7. So when you write the R12, first row, second element, that is R7, and that value is negative. So RKJ terms are negative, and which is the sum of resistance which is common to both the mass K and mass J. Suppose this is mass K and suppose this is mass J. So between that common resistance is R7. So that term is RKJ term is minus R7. It may be possible there are more than one resistance. So if there are more than one resistance, then this term is sum of all the common resistance, and that must be a negative. Same way for the voltage. In this mesh, here there is only one voltage source, but may be possible that in some of the circuits there are two voltage sources in one mesh. So for the voltage, you make the algebraic sum of the independent voltage source and taken as a positive, with the voltage rise taken as a positive. So last time we do this example, three equations, A11, A12, A13. Suppose you assume that is your resistance of first mesh, A21, A22, A23, that is a resistance for second mesh. Same way A3 for the third mesh. X1, X2, X3, that is your current. B1, B2, B3, that is your voltage. So first make the matrix of resistance. This is a current matrix, this is a voltage. So when you find out X1, first find out the determinant of this, that is called as D, and then after find out the D1. So D1 is nothing but, you can see that D1 is nothing but the voltage column that is replaced by the first column of matrix D. B1, B2, B3 replace this A11, A12, A13. Here the remaining second and third column is as it is, so that becomes D1. So when you find out X1, it is nothing but the ratio of D1 by D. It means determinant of D1 divided by determinant of matrix D. Same way when you find out X2, so for that find out D2. So for find out D2, you replace the second column of D by the B1, B2 and B3. So you can see that the matrix D2 becomes first, third column as it is, like this D, and second column is replaced by the voltage source, this one B1, B2 and B3. And find out the determinant, so that gives the value of D2. So the value of value of X2 is what? The ratio of D2 by D. Same way for the X3. Third column is replaced by this B1, B2 and B3. So that gives the D3. You can see here. So find out determinant D3 and then divide with the D, so that gives the X3. So by this way you can find out the three variables X1, X2, X3, or I1. So you can easily understand it. So write down the first example, all of you. Determine the mesh current I1, I2, I3 for the network. First of all of you draw this network. And find out the mesh, number of mesh. First step is find out the number of mesh in your network.
3 mesh.
Yes, very good, 3 mesh. So here, after find out the mesh, assume that the direction in all the mesh is clockwise or anti-clockwise, whatever you want to take. So here I take clockwise direction for all the mesh current. I1 is clockwise, I2 and I3. Clear? Then after second step is what? Second step, Suhadu? Yes.
Make the equations.
Yes, apply the KVL and make the equation. So for the first mesh, you can see here I apply the KVL for the loop 1, mesh 1. So here we have voltage source which has a value 15 volt. So Here we move from negative to positive. So we consider as a positive. Clear? And here this voltage drop becomes across this 10 ohm resistance. So here we consider as a minus. So it is minus 10 into I1. Same way here there is a 5 ohm resistance. So how much current flowing into this 5 ohm resistance? Because the 5 ohm resistance is common between loop 1 and 2. Clear? So I1 current is flowing from this terminal to this terminal in this 5 ohm resistance, and current I2 is flowing from lower terminal to upper terminal. It means current I1 and I2 both are positive, both are opposite when it flow through this 5 ohm resistance. So current flowing into 5 ohm resistance, how much? I1 minus I2. Clear all of you? So voltage drop across this 5 ohm resistance is what? 5 ohm resistance multiply difference between I1 minus I2. Because current flowing through this 5 ohm resistance, I1 and I2 both are in opposite direction. Here you can see that current I1 is from upper terminal to lower terminal, where I2 is flowing from lower terminal to upper terminal. So that's why we make the subtraction I1 minus I2 into this 5 ohm resistance minus voltage drop across this 3 ohm resistance. Same way 3 ohm resistance that is common between loop 1 and loop 3. Here again current flowing through this 3 ohm resistance, I1 and I3 that is opposite. So I1 minus I3 multiply this 3 ohm resistance, that is nothing but a voltage drop across this 3 ohm resistance, and then equalize to 0. So that becomes the equation of KVL for loop number 1. I hope it is clear to all of you. Any doubt, Chairman? For loop 1 KVL? Yes, anyone? Anyone, is there any doubt?
No, sir.
Okay. So here I simplify this equation. Your voltage source is 50 volt. Equalize with the voltage drop. So after simplification of this, your equation becomes 50 is equal to 18 I1 minus 5 I2 minus 3 I3. બધાને આવે છે? બધા કેલ્ક્યુલેટ કરજો પ્લીઝ. બધાને આવે છે આ ઇક્વેશન ફોર લૂપ નંબર 1?
Yes, sir.
Yes, sir.
Okay, then after apply the KVL for second loop. So you can see here we have voltage source 10 volt is equal to voltage drop across this resistance. So how to make the equation? So 10 volt is equal to voltage drop across this 2 ohm resistance. How much? I2 into 2 plus here same 5 ohm resistance that is common between 1 and 2 mesh. So here current is how much? It is I2 minus I1, because here we take this mesh 2 as a reference. So we consider I2 current as a reference. So we subtract I1 from the I2. So that's why for mesh 2, we write I2 minus I1 into this 5 ohm resistance. Here. So you can see that here KVL for loop number 2, voltage drop across 2 ohm resistance. It is minus 2 into I2 minus 10, that is a voltage source, minus 1, that is the resistance common between 2 and 3 loop, and that current is also opposite through this resistance 1 ohm. So we write I2 minus I3 into 1 ohm. So you can see that here I write minus 1 I2 minus I3 minus 5 I2 minus I1, that is nothing but voltage drop across this 5 ohm resistance, or equal to 0. Or you can also write this equation like this way: 10 voltage drop is equal to this voltage drop across this resistance.
Sir, can we copy the question first and diagram also, then solve it ourselves?
Okay. Take your time and draw this diagram, and step by step apply the KVL for first mesh 1, 2 and 3. Okay. So I will wait for 1 or 2 minutes and give you the answer of equation 1, 2 and 3 for mesh 1, 2 and 3. Okay, all of you calculate, please. All of you clear this? બધા લખી દીધું, ડ્રો કરી દીધું છે બધા ફિગર?
Yes, sir.
You get this first equation? બધાને આવે છે first equation for mesh 1? Okay, then apply the mesh 2 KVL. Then KVL for mesh 3. All of you get the answer?
Yes, sir.
Okay, so you get this answer for KVL for loop 2, minus 10 is equal to minus 5i1 plus 8i2 minus i3. Or you can say that 10 is equal to 5i1 minus 8i2 plus i3. Clear? Same way for KVL for loop 3, 5 is equal to 3i1 plus i2 minus 4i3. બધા આવે છે equation?
Yes, sir.
Yes,
Okay.
sir.
Okay, take your time. જે લોકોને નથી
Yes,
આવતું,
sir.
please take your time
Yes, sir.
and get the answer. ભાઈ હું ફાસ્ટ જતો હોય તો મને કહી દેજો વચ્ચે.
Sir, second equation માં minus common કરીને કટ કરી દે તો ચાલે?
હા ચાલે ચાલે. Here minus 10, so you can write positive 10. So 10 is equal to this right hand side, always all this sign becomes inverse. So 10 is equal to 5i1 minus 8i2 plus i3. Okay, you can write like this manner also. Same way for loop 3, you can also this take 5 positive. So the rest of this sign right hand side becomes exactly inverse. So 5 is equal to 3i1 plus i2 minus 4i3, like this way. Okay.
Yes, sir.
Sir,
Yes.
sir, આમાં છે ને આવડા સમમાં આપણે આખામાં જ કરંટ ડિસ્ટ્રીબ્યુટ કરી નાખીએ અને પછી લૂપ લગાવીએ તો ચાલે?
એટલે ખબર ના પડી.
એટલે સર ક્વેશ્ચનમાં આપણે પહેલા આખામાં કરંટ ડિસ્ટ્રીબ્યુટ કરી દઈએ કે એક બેટરીમાંથી કરંટ નીકળે છે, પછી બધી બ્રાન્ચમાં ડિસ્ટ્રીબ્યુટ થતી જાય છે કરંટ. જે 10 ઓહમ વાળા રેઝિસ્ટન્સમાંથી I કરંટ ગયું, તો પછી 2 ઓહમમાં I1 કરંટ જશે, તો 5 ઓહમ વાળામાં I માઇનસ I1 કરંટ જશે. પછી પાછું નીચે જશે તો I1 ઓહમ વાળું રેઝિસ્ટન્સ છે ને એમાં I2 કરંટ જશે, અને 3 ઓહમ વાળા રેઝિસ્ટન્સમાં છે ને I માઇનસ I1 માઇનસ I2 કરંટ જશે. એટલે સર વેરિયેબલ ખાલી બે જ રહેશે, I1 અને I2, અને આ ત્રણ વેરિયેબલ હશે. પછી આપણે ત્રણને આરામથી સોલ્વ કરી શકીએ.
તમને easy લાગે એ કરી શકો છો. See, this is a simple network, so you can do this, but for the complex network it becomes difficult.
Okay.
Here there are 3 mesh, so it is easy for that, but some of the examples have 5 or 6 mesh, and
Yes.
network is become complex. So at that time this method becomes very complex.
Okay.
So this is a very easiest method. So first identify the number of mesh, then assign the sign, direction of mesh current I1, I2, I3, then find out this equation for all the mesh and solve using the matrix.
Okay.
This is a very simple method.
Okay. Thank you,
Otherwise it
sir.
becomes complicated. Okay.
Yes.
Okay, so I think all of you get these three equations. Okay, so next step is what? By using these three equations, make the matrix. So you can see that we have first column of voltage, 3 cross 1 voltage source. So in the first equation, you can see that we have voltage source of 50. So first term is 50. Second equation has voltage source minus 10. And third equation has voltage minus 5. So our matrix becomes 50, minus 10 and minus 5. That is of our voltage. Equal to, this is a resistance matrix. So first row of this matrix that represents the elements of I1, I2, I3. It means resistance element for mesh 1. So you can see that in the first equation we have I1, I2, I3 term. First term is 18. Second term related to I2 is minus 5 and third is minus 3. So first row is 18, minus 5 and minus 3. Clear? As per the equation number 1. Same way, second row that is related to this equation number 2. So first term is minus 5 related to I1. I2 term is 8. I3 term is minus 1. So we write minus 5, 8 and minus 1. Same way for the equation number 3, all the terms I1, I2, I3 write down in third row minus 3, minus 1 and 4. And then here is a vector of 3 cross 1, which is the current vector I1, I2 and I3.
Sir?
Yes?
Sir, is I1 1.89 ampere?
Answer? Yes, I will discuss this. So,
Sir, 3.603 ampere.
Yes. First of all, I give you the step-by-step procedure. Then after I give you the second example for the self-study. First of all, I give you the understanding how to calculate this. Okay, because some of the students maybe not understand this. Okay, so first I explain this procedure. Then after I give you the second example for your self-study. Okay, then after calculate this. Okay, so first we need to find out I1, I2, I3. So when you find out I1, so at that time replace this first column of this matrix by the voltage 50, minus 10 and minus 5. So you get the matrix. So that is called as a delta R1. You can see that first column that is replaced by voltage minus 50, minus 10, minus 5, and find out the determinant. So you get 1175 ohm. And delta R, that is nothing but determinant of this resistance matrix, and that you get 356 ohm. Same way, to find out the I2, you find out delta R2. So delta R2 in this matrix, second column of this delta R that is replaced by the voltage. So you can see that third column is as it is, and second column is replaced by the voltage 50, minus 10 and minus 5. And find out determinant. So you get 355. Same way, delta R3, third column of this delta R replaced by the voltage, and find out determinant. So you get the resistance, which is called delta R3. So you get 525 ohm. I think all of you get this, delta 1, delta R2, delta R3. But then answer.
Yes, sir.
So then you find out the I1. So equation of I1 is delta R1, this one divided by delta R. It means 1175 divided by 356. So you get the answer 3.30 ampere. All of you get this answer?
1 ampere.
Yes?
I2 is 1 ampere.
Yes, I2 is 0.99. So it is almost 1 ampere. It is a delta R2 divided by delta R. And the I3 is delta R2 divided by delta R. So you get 1.47. Clear all of you? But then our answer I1, I2, I3.
Yes, sir.
Okay.
Yes, sir.
Is there any doubt? કોઈ સ્ટુડન્ટ ડાઉટ છે કઈ એક્ઝામ્પલમાં? Because next example તમારે કરવાનું છે. Okay. Okay. So
Sir,
right.
I had a doubt. For delta R1, why do we replace the first row with the?
Not first row. We replace the first column.
Yes. Column.
Yes. This is a method. This is called as a Cramer's rule. આપણે જોયું ને last lecture માં. So Cramer's rule, by using this Cramer's rules, it is easy to find out this mesh current. Okay. So the voltage source તમને મળે છે, the first column, this one, if you replace in this resistance matrix by first column, so you get this delta R1, and this equation is that I1 is equal to delta R1 divided by delta R. So find out the determinant of delta R1 and divide with the determinant of delta R, so you get the answer I1 directly. Otherwise you need to solve all these three equations simultaneously, and it is a very tedious method. Okay, so very simple method is that you apply the Cramer's rule to find out all mesh current I1, I2, I3. Clear, all of you? This is a method called Cramer's rule. That's why we replace this first column with the voltage source. When you find out I1 and you find out I2, you replace the second column of delta R by the voltage source. You can see here. Same way for the I3, replace the third column of delta R with the voltage source. Clear, all of you?
Yes.
This is a method. This is called as the Cramer's rule. So write down the second example. It is the same type of example. Just change the values. Determine the mesh current I1, I2, I3 for this network. All of you solve this example and give me the answer. What is the value of I1, I2, and I3? Here I assume it is a clockwise direction, but you can also assume it is anti-clockwise. Okay, there is no rule that you always consider as a clockwise. In exam, maybe this direction is not given, so you can assume any direction, clockwise or anti-clockwise. So I will wait for 1 or 2 minutes and give you the answer I1, I2, and I3. All of you get this equation for mesh 1?
Sir, following.
Okay.
Yes, sir.
Yes,
So
sir.
here in mesh 1 we have two voltages. One is 7 volt and another is 6 volt. But you can see that polarity, the one voltage source positive terminal that is connected with the positive terminal of other voltage source. So there is a subtraction between two voltage source. When same polarity terminal of voltage source connected with each other, then we consider minus 6 volt from the 7 volt, because positive terminal of 6 volt that is connected with this positive of the 7 volt. If suppose here it is a negative terminal connected with the positive terminal of the 7 volt, then we consider as a positive, it means we consider the summation of two voltage source, 7 plus 6 volt. But here same polarity, so there is a subtraction, 7 minus 1. All of you get this equation for mesh 1? But then Avashay, 1 is equal to 3I1 minus I2 minus 2I3.
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Okay. Then second equation, you get voltage source 0 because there is no voltage source available in mesh 2, only resistance are available. So voltage term is 0. So 0 is equal to minus I1 plus 6I2 minus 3I2. Then Avasha, for loop 2.
Yes, sir.
Yes.
Okay, જેને પણ doubt હોય please પૂછી લેજો, બરાબર છે? Then I will explain you how to get this equation.
Yes, sir. I have doubt in the second loop.
Okay, what is the doubt?
Doubt.
3 ohm resistance. Yes, this is common between. So 3 ohm resistance, how much current is flowing? So loop 2 current is also flowing and loop 3 current is also flowing. But you can see that the current I2 that is flowing from this right hand side to left hand side, where current I3 that is flowing from left hand side to right hand side. So there is a subtraction of two current. If you make the equation for loop 2, so write down I2 minus I3 and then multiply with this 3 ohm resistance. Clear? So that's why you can see here in the equation that we done 3 into I2 minus I3.
Sir, I1 is 3 ampere.
First, this doubt is clear?
Yes, sir.
Okay, okay. Third equation is for loop 3. Here we have only one voltage source, which is a 6 volt. So 6 volt is equal to, you get answer minus 2I1 minus 3I2 plus 6I3. But then how much answer?
Yes, sir.
Okay. So then after, as per the previous example, make the equation. First column is a voltage. So first equation has a voltage 1 volt. Second equation has 0. Third has a 6. So 106 is equal to, here this equation sign is not shown here, but here this is a equal sign, is equal to this resistance matrix. So first row that represents the element of first equation I1, I2, I3, 3, minus 1 and minus 2. Same way for second equation and third equation. So you get this matrix of resistance and I1, I2, I3. So delta R you get 39 ohm. Delta R1 you get 117 ohm. First column of this matrix delta R replaced by the voltage source 106. Same way delta R2 second column is replaced by the voltage source 106. You get determinant 78 ohm. And delta R3 third column is replaced by the voltage source 106 and you get the voltage you get the resistance 117 ohm. So find out I1. So that is equal to delta R1 minus delta R. You get 3 ampere. All of you get this answer?
2 and 3. Yes, sir.
And I2 is 2 ampere and I3 is 3 ampere. Clear, all of you? But then have a chance.
Yes, sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Okay. Now calculate this third example. By using mesh resistance matrix, determine the current supplied by each battery in this figure. Using mesh resistance matrix, it means by using the mesh analysis, determine the current supplied by the each battery. So you can see here in this network or this circuit, we have 5 batteries. Here one B1 is just 20 volt, B2 5 volt, third one is B3 5 volt, B4 5 volt, and B5 30 volt. So the question is that determine the current supplied by each battery. It means you need to find out the 5 current flowing into this battery 1, 2, 3, 4 and 5 by using the mesh analysis. First of all, draw this figure. How many mesh?
3.
3 mesh. Yes, very good.
3
mesh.
So one by one apply mesh analysis and find out I1, I2 and I3. Okay. So this example, I give you the idea. I give this example as a homework because time is almost completed. So I give the idea how to calculate this example. So first of all of you please understand here. So first calculate the I1, I2, I3 the same way as we calculated by using the mesh analysis. Apply the KVL to all these 3 mesh and make the matrix, resistance matrix, and find out I1 delta R1 divided by delta R. Same way find out I2 delta R2 divided by delta R and I3 delta R3 divided by delta R. Then after our aim is what? To determine the current supplied by each battery. So how much current flowing into the battery B1? Yes. How much current flowing into the battery B1? I1. Okay. So your first answer is current flowing into the battery B1 is same as your I1, which you have already find out by the mesh analysis. Here. Same way, what is the current flowing into the battery B2?
I1 minus I2.
I1 minus I2?
Yes, sir.
Okay.
I1 minus I2.
Yes.
Yes.
Same way, what is the current flowing into B3?
I2 minus I3.
I2 minus I3. Here we take as a clockwise direction. But in this example, you get the value of I3 negative. If you calculate this by using mesh analysis, you can see here, you get the I3 minus 3.13 ampere. So what is this negative sign indicates? This negative sign indicates that here our assumption direction of this current I3 is wrong. It means here we consider as a clockwise direction and calculate I3. And if you get the negative current, it means that actual direction is anti-clockwise direction. Clear? This negative sign indicates that the actual direction of current is exactly opposite your assumption. Clear? Here we assume it is clockwise, but actual direction is anti-clockwise because you get negative sign. So what is the current flowing into the battery B3? Now, after getting this current I1, I2, I3, now your current I3 is flowing in anti-clockwise direction in this fashion, like this way. And current I2 is also flowing into this way. So both this current flowing into the same direction.
I2 plus I3.
I2 plus
Yes.
I3.
So answer is I2 plus I3. Current flowing into the battery B3 is I2 plus I3. Now, current flowing into the battery B4, that is same as the I2 because there is no common between battery B4. Because battery B4 is only connected with the mesh 2. That is not common between any two mesh. So current flowing into the battery B4 is same as your current I2. Same as the current flowing into the battery B5 is same as the current I3. Clear? So this example is same as you already calculated the previous 2 example, but just to find out the current in all these batteries. Clear? So here answer of I1, I2, I3 is this one that you find out by using the Cramer's rule, and then after you find out this battery current. Clear, all of you? So this is for your homework, this example. Clear, all of you? Any doubt?
No, sir.
Okay. So first of all, draw this figure and leave this meeting if you have any doubt.
Sir, will we discuss this question next class?
Yes, we discussed this. Yes. If you have any doubt during the calculation, we will discuss in the next lecture. Okay.
Okay, sir. Thank you, sir.
First of all, draw this figure so I can.
Excuse me, sir.
Yes, please.
Sir, do we have to keep I3 as negative or we have to change it because our assumption was wrong then?
What?
Do we have to change, sir, that
No,
negative
no.
sign of
After
I3
that,
or we have to continue?
no. After that, we not need to change because our assumption is clockwise. Okay, that's why we get the negative sign.
Sir, but anyway, we can find either
Yes.
negative or positive.
Sorry.
Anyway, we can find that I3. Means
Yes,
it is
yeah,
negative, then
yes.
is it okay?
But what is your first step is what? Using mesh analysis, you identify the mesh and
Yes, sir.
give the direction of the mesh current. So here we give the direction clockwise for all the mesh. So here I take the clockwise direction for mesh 3. That's why I take the negative sign. Clear?
Okay.
If you suppose take anti-clockwise direction, so you get the positive sign.
Yes, sir.
So suppose suppose initially you draw this anti-clockwise direction and you get the positive sign, then also your answer is right. And here I draw the clockwise direction, so I get the negative answer. So this answer is also right. Clear? Because my assumption is clockwise. Actually, it is anti-clockwise. So your answer is both answer is right. So it depends upon which direction you assume in your first step, clockwise or anti-clockwise. Clear? So that's why when you get this negative sign, write down this sentence. The negative sign with I3 that indicate that actual direction of I3 is opposite to that assumed. Write down this sentence only. Clear?
Okay, sir. Yes.
Okay. Is there any doubt? Anyone? So I can stop this lecture here.
Sir, when will you provide this?
Yes, I will provide all this PPT. Okay, no, don't worry about this. Okay. So can I leave this meeting?
Yes, sir.
Okay.
Thank you, sir.
And after completion of this lecture, you can also see the recorded video of this to calculate this example. Okay. First of all, calculate your own way. Then after, see the answer. Okay. If you have any doubt, then we'll discuss in the next lecture also. Okay, so you can leave this meeting. Thank you, all of you.
Thank you, sir.
Thank you, sir.